something over in the building over there. I'm glad you all found your way over to this building over here. How many of you are attending the monthly .NET SIG meeting for the first time ever? First time ever. Okay, great. That's a lot of you. Thanks. How many of you have not been to one in the last 6 months? Okay. How many are here just because it said we were going to do Visual Basic? No one admitting it. Good. How many of you have well, okay, let me just give you an introduction for it. So this meeting is held every month, except in very extreme weather conditions. I think we canceled it twice in the time that I've been at Bennett Adelson. We do it on the second Tuesday of each month in some building or other around this area. We used to be doing it up in Microsoft's place, but then Microsoft stopped having somebody available to lock the door behind us every night, so they are making us go to other places in the building. The nice thing about being down here is that there's internet down here, and there isn't any in Microsoft's. Well, there is, but not for outsiders. So you can get on your cell phones, your Wi-Fi, and everything. If I bore you too much. We meet on the second Tuesday of the month with topics generally chosen having to do with .NET or related technologies. We also have a couple other meetings that we hold. If you go to the Bennett Adelson website, which is, I think you just find it at www.bennettadelson.com, we have other events, some on a regular basis, some not. We just recently started up again a programming SIG on the 4th Thursday of each month, which is on the F# programming language. How many of you are here tonight just because it said it was going to be about F#? I was getting my hopes up. One hand went up. Okay. So this is kind of an unusual presentation for me because I decided to do it in 3 different languages. And I'll confess that I was mostly successful, but I ran out of time at the last minute. And one of my projects is only in C# and F#, but I will translate it into Visual Basic before I put the stuff up on the web. You'll be able to get the slides from this talk and all the sample code you're going to see in, maybe by the end of the week or, within a week's or so time frame if you're so interested. And I will, of course, have all the mistakes corrected and all the missing parts filled in, and you'll think it was like a whole different presentation. How many here have done asynchronous programming before? Lots of hands go up. How many of you enjoy doing asynchronous programming? How many of you can't stand the thought of it? What are you doing here? So how many have done asynchronous programming with the task parallel library? A few hands. Okay. All right. What I'm going to do is, how many of you know what asynchronous programming is? Okay. Asynchronous programming is something that's been in .NET ever since version 1.0, but it's changed. And it's changed by addition, not by subtraction, in that each major release of .NET seemingly has brought along something new in the field of asynchronous programming, as if they hadn't yet gotten it right. And the last 2 releases of .NET, .NET 4.0 and especially .NET 4.5, really a huge part of what's really new and makes the marquees for Microsoft has to do with this task parallel library and the new paradigms for asynchronous programming that it introduced. But we had plenty of them before. One thing that I found out as I was preparing for this is that it was kind of hard to compare task parallel library with previous things because there's so many previous things. And if you open up a book on the subject or you go to somebody's blog or read an article on MSDN, it'll say task parallel library is different compared to this, and it'll mention one of the other major flavors of asynchronous programming that is already out there, but not all the others. And we can all say that we've done asynchronous programming, but I would be very impressed by anybody who's used all the different techniques that have ever been out there from day one. Although some of you probably have, and maybe not maybe without realizing it. So what I want to do first is go over the existing technologies before .NET 4.0 and compare and contrast them, and then get into some of the things you can do with the newer stuff. Now, how many of you have programmed in F# before? A couple hands go up. F# had its own unique asynchronous programming technique that was out considerably before task parallel library. It's been available for as long as there's been an F#, which goes back, at least to 2005, I think was the first 1.0 release of it. So some of the things you're going to see that are now in C# and VB.NET have been in F# for quite a bit longer. And there still are a few things that F# does either a little differently or a little better than TPL does. So I'm going to go over samples in F# that are not repeated in the other languages because they don't have the stuff that I'm going to be showing you. But the disparity between them is a lot less than it used to be. So, okay, so here's me. Tweet me at Surreal. That's my email, and that's the public Bennett Adelson website. So, I'm going to talk a little bit first about what asynchronous programming is. Since most of you have done some, this should just be a quick review. Then I'm going to go through a survey of asynchronous programming techniques. That's going to cover samples from all three of these languages, going from simple thread manipulation all the way up to .NET 4.5. Then I'm going to do some more advanced topics, and we'll talk specifically about parallel. We're going to start out focusing on asynchronous, and then we're going to focus on parallel. Who knows what the difference is if I say asynchronous programming versus parallel programming? Hand goes up. I haven't asked the question yet. Are those the same? Do those mean the same thing?
No.
They don't. What's the difference? Never mind. I'll tell you. So that's one of the first things we'll talk about. What is asynchronous programming? At the very least, it means running two or more functions concurrently. Okay? Usually by running on separate threads, but not necessarily. Okay? So what do we mean by concurrently? Concurrently means that work is being done in more than one function, either at the same time or switching back and forth so fast that it might as well be at the same time. I guess I should back up one more step. Does everybody know what a thread is? Because I'm really not going to stop and explain processes and threads and Windows versus Linux and all that. So the other key thing to not forget about this is that we're talking about functions. In all the different variations of asynchronous programming and parallel programming, the thing that gets run concurrently is a function. And I'll use this term kind of generically in the C# sort of sense, or F# sort of sense, as a unit of code that takes some or no inputs and returns something or nothing. Okay? In VB we have the distinction between functions and subs, but I'm talking about either one here. The point is that a function does some work, and when functions run concurrently, they're able to have more than one function doing work while another one is doing other work. And then usually in asynchronous programming, once you get all these different functions running, two or more concurrently, you have to do something about coordinating. And that has two dimensions to it. One is coordinating control. If I give control of a particular function to, say, a thread, and it starts running off and executing it, how do I know when it's done? Do I care about when it's done? Suppose I have several running and I want to know when they're all done. So, or maybe I don't. Maybe I want to just go right on. Then there's the question of data, coordinating the data. Each thread might be acting on some data. Is that data interrelated? Do they have, are they sharing data, or are they working together on data that's going to be combined in some way after they're all done? All this, and all these sorts of things have to be taken into account when you're doing any kind of asynchronous programming. Okay, so concurrently might mean simultaneously, and it might not. Truly simultaneous execution of functions is only possible in today's computer architectures if you have multiple CPUs and or multiple cores in your computer. If there's just a single processor with a single core inside, which is what almost all processors were until a few years ago, then you can only truly have one thread running at a time. And this has been true, ever since Windows 3.1 and before that. Nonetheless, we do have multi-threaded programming even when there's only one processor and one core, and that's achieved by switching, by moving, by giving a thread some time, let it run a little bit, and then somewhere down the operating system there's something that will say that's enough, time's up, we're now going to let another thread have a turn. And each thread runs as though there were no others, or at least unaware of the fact that there might be any others. But in fact, only one is running at a time, but they're all getting started and stopped without knowing when and why. And through the miracle of protected mode 32-bit Intel architecture, all this works more or less transparently, even when there's only one CPU. But today the norm for computers is multiple CPUs in the machine, and especially when you're talking about most laptops today and most smaller computers and even desktop computers, multiple cores inside the CPU. And I'm not a hardware engineer, so I don't want to try to explain what the difference is between multiple cores and multiple CPUs. The fact is that each core can run its own set of threads independently of all the other cores that are in the machine. And so you can have, this computer has 8. It has an Intel i7 chip inside, which has 8 cores. i7. There's i5, which I believe has 4 cores. i3, I think, has 2. Is that right? Close enough. So, either way, the operating system is going to have to do some work to make sure all this stuff runs in a coordinated fashion. So, concurrent execution, no matter how it's done, is not free. It imposes overhead. It slows things down. Running code concurrently is almost certainly not going to be faster if you only have a limited number of threads, or you have a limited number of threads that can run at a time. Then the overhead taken up by context switching is going to make the whole thing slower than it otherwise would have been. If you have multiple threads that can run simultaneously, multiple cores or CPUs, then you might get faster performance, and you're hoping that you will if you have a lot of them. But there will still be overhead to pay for that will detract from whatever performance improvements you get. Why do you want to do asynchronous programming if it's expensive? It may very well slow your code down. Oh, and it's difficult too. Don't forget that. Why would you want to do it? The number one reason up to this point in time in .NET programming, and it's still, I would say, probably the reason most commonly why people do it, is to prevent blocking. Blocking is where a thread is moving along and it does something that's going to take time. It's going to take time either because there's some resource it needs that's not available right then, and or because it has to do a lot of work. It just has to do a lot of work, and it's going to take a while. While this one thread is blocking, you've got other work you'd also like to be doing, and so you hand it to another thread or another function, and you say, you go run while this other one is sitting around, taking up time. That's the prevention of blocking. Responsiveness is a special case, and a very common special case, particularly in user interface programming, where you want the application to be able to receive new inputs quickly. Okay, you want to be ready for more input that might arrive at any point, and you don't want to be slowed down by inputs that you've already gotten, even though you're not done with them yet. Thread isolation, what I'm really talking about here, what I have in mind here, also relates to UIs. As how many of you have done Windows Forms programming? How many, or if you've done Silverlight, or if you've done any kind of phone programming, or Windows 8 programming, or WPF, Presentation Foundations programming. All of these user interface types of programming always have a thread in the application, which is the user interface thread, the UI thread. And it goes by different names, and there are different variations on the APIs that deal with it. But there's always a sacrosanct rule in these style of programs where the user interface objects that people actually see are only allowed to exist on the user interface thread. They're created there, they're destroyed there, and only the user interface thread is allowed to touch them. Okay? That's because the user interface thread is running an illusory concurrent operation where it's actually going through a big loop, pausing at each control, asking it, do you have something new to tell me that's happened and the user is done, like click, button have you been clicked, text box have you been written to. And it goes through a big cycle through all these controls. If other threads are allowed to come in and mess with the controls while the user interface is constantly going around checking them, chaos will ensue. So you'll get a runtime error, most likely, if you try to touch a user interface control and you're not doing it from the UI thread. And then lastly, the point about taking advantage of machine resources. If you do have lots of CPUs or lots of cores, lots of RAM, lots of disk, lots of storage, and you want to take full advantage of it, you might want to have it, force it to do more work than you otherwise might need it to do, just because you don't want to waste all that hardware that you're paying for. Okay, so here's more detail about each of those points. I already said most of this. Frequently, when you talk about blocking, the things that block are I/O related, input-output related, like calling to an external service that's slow to respond, doing a SQL query against a database that's slow to respond, pushing a file over the network that's real big and slow to get to where it's going. Then you have other threads that may be, totally self-contained.